Okay, so now we have in the game manager, we can calculate the current board state. Now we are going to use a couple of methods to see if a specific cell can or cannot move. So in game manager, I'm going to collapse the calculate board method, and we are going to create a public bool check for overlapping cells. And just to make sure, we are going to take in a vector free and call it cell position. So what we are going to do is for every item, for each is what we want, var item in cells, we want to see if there is a cell in this specific position. So what I'm going to do is I'm going to check if this item in cells dot transform dot position is equal to our cell position. We are going to return true because yes, there is this needs to be an if statement, because in this case, yes, there will be an overlapping cell. If not, we are going to return false. But because we are still inside the loop, we need to return that false over here. And because as soon as we hit a true value here, it returns and it will not continue with the loop. It automatically breaks out of the loop. So after this, what we are going to do is in the cell piece, we already have the tile map to see where to move or if there's a tile next to the specific cell. So we need to check if this tile that we get is equal to null. Now, null essentially means nothing. So we want to see if a cell that in this specific position, if there is a tile, if there's not a tile, we want to continue. If not, we are going to return a false. So, and after this, we need to do another if statement, if, and this is where our singleton pattern will come in handy. If game manager dot instance dot check for overlapping cells, and then we can feed it in cell. If it returns true, that means there's a cell in this position, so we need to return a false from here. If not, we can return true. That means there is nothing in this position. And once we click 0, we should see, oh, we have a problem. Once we click 7, we still have the same problem. Double click on this to see where everything goes. We never set the tile map within cell piece. So if we go on to awake, we can say tile map equals to game manager dot instance dot tile map. Because that is a public variable within game manager on top of here, we can get access to that. So we go back to our game and hopefully this time it will work. So now we say we can move. Now we can go on with the logic of the move cell method. First, we need a bit of code to tell the can move method where this cell is in relation to the grid. Okay, so once we have that cell with 1C, we need to test if the cell can move in up, right, down, or the left direction. So in every single one of these methods, we will see, okay, we will test if we can go up, we will test if we can go right. And because there's only one possible move per cell, if there is a possible move, so if this can move, returns a true. From there, we can perform the move. So let's quickly do that. It's going to be a very simple method called perform move. Okay. All I did here is I get the cell center. For instance, in the tile map, it may be a certain XY coordinate. All I did is I turned that XY coordinate into the world space XY coordinate, and then I set my current position to that. So now that I have that, I have can move and perform move. So on here I go. First, I will start with a simple if statement. Okay, so all I am doing now is performing some basic vector math. All I'm doing is, at this current cell position, I want to see if there is anything on top of this. If not, or if I can move in that to that position, I'm gonna simply say perform move, and I'm going to add this new vector in there. If you want more information on any of the tile map mathematics or mechanics, I did include a video in the second video. I did include a link in the second video to a wonderful and epic tutorial on making Bomberman with the tile map system in Unity by a much better creator than myself. So if you are confused by all of this, just go watch that video. I highly recommend it. So all I did now is I repeated the if statement over and over and over and over for each of the 4 directions with the corresponding vector directions or vector positions in for every single one of them. The reason I can do this without hitting return or break is because there's only one possible move for every single cell. So if I were to close this or minimize this, and within our on mouse down, what I'm going to do is I'm going to, as soon as I click on it, I'm going to move it. So hopefully, if I go here to the game itself, if I click on it, it hopefully moves. And we have our first problem. As you can see, if I click on 2, it does not want to move. If I click on 4, it moves left, then down, then right, then left. And so we have our first problem, ladies and gentlemen. It would seem that the program registers the tile map around it, but not cells, but not other cells. So there is a problem in our check for overlapping cells, but I do not think it is the check for overlapping cells that is the problem. I think it's the information we feed it. Essentially, we're feeding it in a vector position that's representative of the cell's position on the tile map, not in the world. And the data we have saved is positions in the world space. So to fix that, what I'm going to add is I'm going to control X that, get cell center world. If everything works correctly now, we feed the method the correct data and we put in the correct data. This should work 100% fine. And as you can see, the 5 follows the rules, the 7 follows the rules. And now we can click on all of the cells to see that it moves 100% correctly.